So you probably think you know all about 3D printing, right? That amazing technology that's totally changing how we make stuff. Well, what if I told you it's kind of yesterday's news? Seriously, let's dive into the next evolution, 4D printing. And this is where things get really wild, because the objects we create are no longer just static things, they're practically alive.
Yeah, I know. 3D printing is outdated. That's a pretty bold claim, right? But this isn't just hype. We're not talking about a minor upgrade here. It's a complete reimagination of what an object can even be. We're moving from printing passive, lifeless things to printing active, dynamic systems that can transform and adapt all on their own.
Okay, so here's the fundamental difference in a nutshell. 3D printing gives you an object's form, its length, width, and height. You get a fixed, static object. But 4D printing adds that crucial fourth dimension, time, and that changes everything. It means an object isn't done when the printer stops. It can literally change its shape, its properties, or even its function after it's been made, all in response to the world around it.
So here's how we're going to break this all down. First, we'll talk about this new dimension. Then we'll get into the nuts and bolts of how it actually works. After that, we'll look at the incredible things these objects can do, imagine the kind of world this could create, and finally, check out what's next on the horizon. This whole concept actually got its name back in 2013 from Skylar Tibbetts at MIT. He and his team at the Self-Assembly Lab had this amazing vision, a future where we could print things that weren't finished, but were instead programmed to become something else entirely. So here's the more official definition. You're essentially creating something that can change itself when it runs into a specific trigger, that could be heat or water or light. It's basically programmable matter. Think of it like this. It's like coding, but instead of writing instructions for a computer program, the instructions for the transformation are built right into the physical material itself.
But how on earth is that even possible? I mean, how do you program a physical object to fold itself up or change its properties? Well, it all comes down to three key pillars. And these three pillars have to work together perfectly. First, you need special smart materials that are designed to react to a specific trigger. Second, you need an advanced 3D printer that can precisely lay down these active materials right next to regular passive ones. And finally, you need some seriously powerful software that acts like a choreographer, planning out every single bend, twist, and fold before the object is even a real thing.
Now these smart materials, this is where the magic really happens. We're talking about stuff like shape memory polymers that can remember an original shape and snap back to it when you warm them up, or hydrogels that just swell up when they touch water. There are even electroactive polymers that contract like a muscle when you hit them with a bit of electricity. These materials are the tiny engines that drive the whole transformation. So when you put all those ingredients together, you get these objects that really do seem to come alive. And their transformations aren't random at all. They follow a very specific, pre-programmed path.
The two main ways this happens are through self-assembly and shape-shifting. With self-assembly, just picture printing a flat-packed box that, when you drop it in water, folds itself up. Simple as that. Shape-shifting is a little different. That's when an object that already has a shape changes its geometry. A great example is a medical stent that expands to the perfect size once it warms up to your body's temperature.
And if you want to take this a step further, you get to self-repair. This is where it gets really sci-fi. We're talking about an object that can sense when it has a crack or a fracture and then just heal itself. This could make things last dramatically longer.
This all sounds incredibly cool, right? But why does it actually matter? Well, the potential uses for this technology could fundamentally change just about any industry you can think of.
Let's start with medicine, because having an object that can adapt to the inside of the human body, well, that's a complete game changer.
This could be the end of one-size-fits-all treatments. Imagine a smart pill that only releases its medicine when it detects you have a fever. Or a scaffold for growing new tissue that guides cell growth perfectly and then just harmlessly dissolves away. We could even have tiny, soft robots that can navigate through your body to perform surgery without making a single large cut.
All right, now let's jump from the human body to the skies and beyond. In aerospace, performance, weight, and autonomy are absolutely everything.
In this field, 4D printing could solve huge problems with efficiency and safety. I mean, think about airplane wings that subtly change their shape during a flight to always be perfectly aerodynamic. That would save a ton of fuel. Or what about satellite parts that are printed flat to save space on a rocket and then just assemble themselves into complex structures once they get to orbit?
But this technology isn't just for, high-tech labs and space missions. It could easily find its way right into our daily lives.
What if your jacket could adjust its own ventilation based on your body temperature, keeping you comfortable all the time? Or shoes that perfectly conform to the unique shape of your foot as you wear them? Even something like your food packaging could change color or shape to give you an unmistakable sign that, hey, this is no longer fresh.
So, when can we expect this amazing, transformative future? Well, like with any truly revolutionary technology, there are still some pretty big hurdles we need to clear before 4D printing goes mainstream.
The upsides are obvious. You get incredible adaptability, lower assembly costs, and even that self-repair capability. But the challenges are just as real. For now, the smart materials are limited and expensive. The design process is super complex. And of course, there's the big question of how to scale this up for mass production.
But you know, the long-term vision here is so much bigger than just a self-folding box. The ultimate goal is to create systems that are almost living, things that can sense their environment, make a decision, and then adapt their form or function completely on their own, a lot like a biological organism.
And that really leaves us with a final massive thought. 4D printing asks us to stop thinking about manufacturing objects that are static and finished. It pushes us to imagine a world where the things we create aren't just built, but are born with the ability to grow, change, and adapt to the world around them.